Good afternoon, everyone. I think you can start now. So, Dr. Lee Martin is a professor of practice in the UT College of Engineering. He's directing a minor in engineering entrepreneurship. Sorry, yeah, this is electrical engineering, so I get carried away. So he founded Telerobotics Inc., which went public in 1999. He holds 20 US patents in technologies related to telepresence, remote imaging, and battery charge sensing. He holds mechanical engineering degrees from the University of Tennessee and Purdue University. He received 2 awards for product innovation, one for telerobotic controls and the other for omnidirectional imaging. He also authored the book Techonomics that anticipates the virtual age, and that's what he's going to be talking about today. So I will be handing over to him right now. Then please can we welcome Dr. Lee Martin.
Well, thank you, Stephen, and I'm more than happy to make this interactive. If you want to ask questions as I go along, just raise your hand. We'll be glad to stop in the middle. I'll also save about 5 minutes at the end for questions. Enjoy your pizza, stay awake, enjoy your emails, whatever you're doing on your machines, because these aren't posted. But anyway, fire away. Techonomics, dawning in the virtual age. What I want to share with you today is how to put on a separate set of glasses to see what's coming, to take a look at what the developments are headed towards the future. And I want to do that by looking at my past, my technologist past, some things that I saw along the way that changed the way I looked at the world, and perhaps give you a different set of vantage points for how you look at your world as it's coming ahead. This is where we're going. We're going to talk about virtualization, and I want to convince you that you are right smack dab in the middle of the virtual age. I'll define what that is, and we'll talk about why I believe that. We're going to talk about early C's. I'm going to take you back about 40 years to something called telepresence and how I came to see the world in this way. Then I'm going to condense things down into 3 keys of Techonomics, technology, economics, that I think are massively changing our society as we speak. It's changed it since y'all were kids. It's going to change it throughout your career. And I want to give you the 3 key exponential trends that are irreversible and are the immovable force in that. Share with you how that converges to what I call the virtual age. Give you a couple of thoughts on how to spot the trends that you're in the middle of to see where things are going. Kind of like Wayne Gretzky, the great hockey player, was asked one time, how did you become such a great hockey player? He says, I don't skate to where the puck is, I skate to where the puck is going. And so you need to plot your career to figure out where the puck is going, where technology is going, because if you're designing something that is a couple of months away, that puck is going to already be past you. And then finally, a little bit of a thought on a refined message for you for current and your messaging. Virtualization is telepresence through evolution, through some things I'm going to share with you. Techonomics with increased telepresence. Telepresence is this idea, takes the Greek word tele, which means at a distance. Telephone, television, telescope, the ability to see video from a distance, the ability to see things from a distance, the ability to hear from a distance. Telepresence is that thought about being able to be present from a distance. So it's the idea of capturing all of your senses and being able to go teleport them somewhere else that you're not. Techonomics is this idea about how technology is the evolving agent of change. We do things differently today than we did 5 years ago because there's new technologies and there's better ways to do it. But the ones that survive over the long term are the ones that have economic benefit. So for every 100 ideas, there may be 5 that ultimately last for a generation, that last longer. So Techonomics is this look and a vantage point about all of these trends and trying to spot the economic trends that they support so that you can be banking on the right ones in the future. This trend towards virtualization, I'll do this a couple of times, but this is where I'm going and what I'm trying to convince you of. What is virtualization? In essence, it's the ability to do more and more with less and less until you can do just about anything from just about anywhere, just about any time with almost nothing at all. All right? And when you get to nothing at all and able to do it anywhere at any time, it's virtual. All of a sudden, the things I used to do with you personally and in personal contact, I can do with 1 million people around the world anywhere at the speed of light. That's this concept of virtualization. And there's a lot of technology pieces that have come together only in the last decade to 15 years that are making virtualization a reality. We'll talk about those. It begins with telepresence, and this is kind of my journey. The virtual age, if you think about all of these, we've named the ages through time. You see the industrial age in the 1800s, which started with Watt's steam engine. We see electrification in the 1880s. We see the communication age in the 20s, the space exploration age beginning in the 50s, computerization in the 70s, digitization in the 80s, globalization in the 2000s. And what I'm saying is those are getting compressed in time, and they all really have key inventions that launch a new age. We are in that virtualization age now. Telepresence, robotics for hazardous environment. This was the first work that I did as a working engineer, not a student. Was out at the Oak Ridge National Laboratory. And the idea of telepresence was to create force-reflecting bilateral servo manipulators. What does that mean? Think of a robot. I've got a robot in a hazardous environment. Think of that being outer space or inside of a hot cell, radiation or otherwise, or massively underwater. And I have a second robot in a safe environment interacting with a human being. And that human being grabs that safe robot, makes a motion, and that hazardous robot replicates it. Not only does it replicate it in real time, it can magnify it. It can magnify the motion range, it can magnify the strength, it can magnify the touch, and we have the ability then to manipulate, to be present somewhere that we're not. This is what it looked like in an installation back there again in the early 80s with the master control room. You see these manipulators. They were digitally controlled. We developed the first digital controls of those, moving from analog to digital through a communication system that then controls a gantry and a slave system. So you can see that kinematically, this is the same as this. When this runs into something, this guy feels it. When these cameras see something, he sees it on these monitors. So all of a sudden, I can see, I can hear, I can touch, I can feel, and I can move, and I can do that all in real time. Now, in real time is a little bit different, though, because even the act of putting a simple bolt, threading a bolt, takes about 8 times longer with these machines as it does doing it in person. It just has to do with how accurate they are, how well they work. But if you think of the human condition as senses and intelligence, we begin to see that we've begun to replicate these things. We've got television, vision at a distance. We've got the telephone, speaking at a distance. We've got telepathy, perhaps. We've got teleportation, telekinesis. For the future, we have telemanipulation, combining the eyes with the hands, and we have this idea of virtual vision. One of the problems that became aware to me at the time was the fact that these manipulative conditions for moving the cameras around were large, they were bulky, they were slow, and they kept running into things. It's like sticking your finger in your eye when you're trying to do close work. And they were failing all the time. So the idea came, why not put a fisheye lens on here, which gives you a 180-degree field of view. You can see everything in a hemisphere, like a basketball, and I can then take the portion that I'm interested in and create what you might call a virtual pan and tilt. The ability to look any direction that I wanted to without mechanically moving anything. NASA funded it, started a company around it. It was an interesting opportunity as time went on. Just so you'll understand what I'm talking about, hopefully this will cooperate here. It did earlier, we tested it. This is an example of a picture that has been done with this technique. And so you'll see, this of course is the Sistine Chapel. You see the ability to see things. There's nothing moving. This is a photograph. Ultimately, these photographs became used primarily for real estate and those types of things. So hopefully I can get back. Very good, very good. Here we go. So that is my idea of a virtual pan and tilt. The proposal was simply to accomplish visual pan and tilt with no moving parts. And at that point in time, nobody had ever heard of that. So it was kind of an interesting approach. Figure that was going to happen? Yeah, I lost focus. All right. Okay. Thank you. All right. So that's the telepresence side. The idea of being able to do anything at a distance and ultimately anything virtually. Now let's talk about the Techonomics side, where technology is driving change in society through economics, and we're going to apply it to that telepresence idea. So technology is the initiator of change. The economy is the filter to determine which changes have value to society and therefore live to perpetuate, almost a Darwinian approach to looking at the economy. I wrote a book about 12 years ago called Techonomics, the Theory of Industrial Evolution, and what I want to do is give you a very, very brief synopsis of the top level of what was in that book. 3 laws. First of all, I made up the term Techonomics, so therefore I can make up the laws. There will be those of you that are purists that will say, well, these aren't laws. And certainly they aren't laws, they are postulates. But nobody's proved them wrong yet. It's been kind of interesting to see how they happen, okay? So there's 3, and you with computer science and engineering backgrounds should not graduate from a 4-year university or a master's degree without knowing these 3 people and what they did that contribute to the way your life is being changed massively right now. The first is Moore's Law. We'll talk about in more detail, but I just want to give you a top level view first. Moore's Law, exponential electronic performance advancement. And you can put quotes around performance advancement. That's either the drop in cost or the increase in speed. We'll talk about what that exponential is. Exponential is in blue on purpose because these are not linear effects. They are exponential. They are inevitable. Don't try to fight them. The second is Metcalfe's Law, exponential network interconnection. And the final one is Coase's Law, perfect information, diminishing organizational size. Let's dig a little deeper. If you go back, the story of Gordon Moore, he was a graduate student at Stanford back in the early 1960s, not unlike many of you are graduate students here. He probably had the same challenge as you have. He stayed there a long time. And in a period of 4 years, he saw 2 generations of these things called silicon wafers, where they were putting Scotch tape on them to mask them in order to make integrated circuits. And in the 2 segments, 2 years that he was there, he saw them be able to shrink and get twice as much computational capability out of the same wafer. The wafer was a fixed size and a fixed cost. Very expensive, mind you. It was silicon and gold, all right? But how you cut it and how you put on your traces would determine how much value you could get out of that. So he made a simple observation, a simple postulation that in the 1965 paper for IEEE, that basically said, I think every 2 years, the price of computing is going to cut in half, or for the same amount of money, the speed is going to double. Simple postulation. It's become known as Moore's Law. He later on went to co-found a company that you're very familiar with called Intel. To my thought process, it's probably the first company in American history and world history that cannibalized its own product every 2 years. And the fact of the matter is, Moore was very prescient about what he said, but he was wrong. It wasn't every 2 years, it was every 18 months, as this chart shows. This is a log linear plot, log in the number of microprocessors in the latest rendition, linear in time. So if this was a linear plot, you've got the hockey stick and it's gone out the ceiling. We've got logarithm here, linear here, and what you'll see, the straight line would represent a perfect 18-month doubling of the number of microchips, number of transistors in the latest microprocessor for Intel. Starting in 1970, 4004, the 8008, et cetera, from a few thousand transistors up to several billion transistors. You of the least of any audience that I talk to are probably not sitting there going, so what? A lot of my audiences go, so what difference does it make? This is the difference it makes. This is my audience participation. I am certain that every one of you has a cell phone in your pocket. So this is the only time I'd like to be out during my presentation, but if you will, pull your phone out, your smartphone. Do a little, hello? Pull your phone out. It's in your pocket. Everybody's got it. Hold it up. Pump it 3 times for me. Let's get alive, folks. Live. All right. You're now holding above your head more computational capability to put a man on the moon in 1969 from the country in the world that had the most technological prowess and an infinite amount of money to spend on it. That's in your pocket. Oh, did I say you're now holding 32,000 times that much computational capability in your pocket? That's exponential change. 32,000 times more computational capability than put a man on the moon in a lunar module in 1969. Now, the old gray man, the guy with the gray hair, he lived through it. He's seen that. It's amazing how it's changed our life. You take it for granted. What's my message for you? whatever you can computationally conceive. I don't care how hard the algorithm is. I don't care what supercomputer you've got to run it on today. There's going to become a time in your career that that's going to run in your pocket. Think big. Think creatively, right? Where my country goes? Right here. All right. So the point here is that that was the Palm Pilot, and that was 1995, in which we crossed that over. What's the implications? What are the societal implications? The death, the demise of bureaucratic labor. What's bureaucratic labor? That's the checkout counter. That's the bank teller. That's the secretary at the phone tree. That's a lot of jobs in our society, and they are vaporizing very quickly. How many of you use Siri? Yeah. Hello, Siri. In the late 1990s, mental human labor became much more expensive than machine intelligence. Labor down, productivity up. So we're also seeing massively vanishing product life cycles. Think about how we download a new update to our operating system in our computer. It probably happens more times than you realize it, particularly if you put it on automatic, all right? It used to be, they didn't update operating systems for years. It had to be right when it went out. Now it doesn't, because if we find a glitch, boom, we can fix it in 24 hours and get it out to everybody. Metcalfe's law. So that's Moore's law. Gordon Moore, founder of Intel, graduate student at Stanford years ago. Moore's law, Metcalfe's law. Bob Metcalfe came along in the 70s, and he said, what if we could stick a board in the back of a PC and have it talk to another PC? What a cool idea. And so he did. Made these little things they could talk together. He had two PCs, got one connection, made it work. That's neat. Then he got another PC, stuck it in there, and he's got, hey, I got 3 connections, but I only added 1 computer, but I added 2 connections. If you look at it, it goes up exponentially. The number of connections goes up exponentially, not linearly with the number of users. And it's completely changed the way that we communicate. Where are we today? We don't even need lines now. We don't need wires now. We've got the cloud, which means that what used to be called the distance of 7. If you knew the right 7 people, you could reach anybody in the world. Now you got to know their email address and have a person to talk to. Okay, so the things that come closer together, connectivity exchange, and that in blue on the bottom is kind of amazing because that started from nowhere in the mid 1990s to 91%, and that number is about 2 years old. It's probably 93, 94% now. Of the world's population lives within the range of a cell tower. That means the whole world's population is open to you if you've got a great idea virtually, okay? It also means that the Bedouins are now camping not where there's water, but where there's cell towers so that they can do business. It's an amazing change in society, even to that level. The impact of Metcalfe's law, we're now a network of networks. We're all interconnected. The virtual world is upon us. E-retailing, e-tax returns, email, e-marriage, and your job description in responsible positions isn't a 40-hour week anymore. It's 7/24, 365. You are on call for whatever purpose all the time. It also means that virtual companies are showing up. They're able to grow massively in their number of users and on their impact much more quickly than ever before in the history of humanity. The third law, and this is not quite as technological a law, but I think equally as important. There was this guy named Ron Coase. He was a graduate student in economics at Oxford in England. He comes to Detroit, Michigan, and we're on the way back machine to about 1930. And he studies, with his economic background, he has one question. If the government doesn't tell a company how many people to hire, how does the company figure it out? Because this was in the rise of socialism, the rise of communism, and central government telling the businesses how many folks they had to hire versus the company itself. So he just wanted to figure out, how did Ford Motor Company understand how many people it had to have to do what it did? So he goes to the River Rouge plant in Dearborn, Michigan, and he studies it. That's a plant at the time that was probably the precursor of mass manufacturing. You know, dirt and iron ore and coal came in one side, and a couple of days later, out go Model Ts by amazing numbers. Ford didn't have too many suppliers. There weren't too many people that could make that number of fenders and that number of tires and that number of bearings and that number of engine blocks. So they were what's called vertically integrated. What Coase saw, or what he theorized, is a day will come when information will become perfect. So what's perfect information? Think about some characteristics of what makes information perfect, okay? It's available everywhere. It's at the speed of light. It's accurate. It's verifiable. It's all encompassing. You get what I'm saying? What does it sound like? Sound like the internet, doesn't it? So I'm still holding out Coase for his paper in like 1933, where he talks about transaction cost analysis, the make or buy decision, and how that's affected by information. He got the Nobel Prize in economics in 1994, like 60 years later, right? Because he was right. History proved him right, because our automobile manufacturing stuff went from being vertically integrated to being supply chain, and a combination of supply chain. And what we do is we exchange information to find the best opportunities, and we can track it all the way. So interesting story about Ron Coase. He said that when perfect information becomes available, well, of which the internet comes close, except with all the fake information, now you still got to have discernment. We would swing that pendulum from the make side, where I have to make everything like Ford used to the buy side, where we can find suppliers that provide it very well. The ramifications of perfect information: all information is instant, accessible. Be careful of hidden transaction costs, meaning if you get into a sole source situation, you may have difficulties with switching costs, you may have difficulties with quality. The make or buy decision is more than where can I get my cheapest vendor. It's about a lot of considerations related to quality, related to protecting trade secrets, related to deliverability, et cetera. But the results, massively increased competition, because now you've got a worldwide reach to try to find your products. Pressures on margin, because now it becomes hyper competitive because everybody knows when somebody's buying something, and an increased accountability because you have users that can post about the quality of your product beyond your control. So I like to say what these three laws have led to is what I call the great virtual convergence. You might first of all call it the great digital convergence, as things went from analog to digital, but I think it's turned into the great virtual convergence as we just piled layer upon layer upon layer of the cloud and higher bandwidth and higher computation capabilities. So what we do is we start at the top in the funnel there. That's not a very good funnel, but that's the idea. With a bunch of tangible things that you might have seen growing up, like a shopping cart, like a real one, not one on Amazon. Like a telephone. That, by the way, the thing on the upper left corner, that's what's called a telephone. It's an icon. That thing with the ears, that's a television with rabbit ears. I'm sure you've seen those things, right? Only the old people are not. They're the only ones laughing. So you ever getting that? Every one of those was a tangible thing. A calculator, real dollars. Okay. The typewriter, portable, CD, you get the idea. Well, we turned the crank a time or two, and we went analog to digital. And that happened in a heartbeat between about 1965 and 1980. As everything was analog, then this thing called the microprocessor comes along, and we realized, hey, if I'm digital, I can pass all of my sensors and all of my information along one line, not have to have a single line for everything. And so, now, if you have the privilege and the pleasure to walk into a nuclear power plant, you get to see cable trays that are this gargantuan. Why? They were designed in the 60s, frozen in the 70s, and they haven't applied anything since then because overregulation. Right? If you got any buddies in nuclear engineering, warn them. Sorry. I'm going to say proud with a bunch of double A's. But it's the perfect example of what's happened. All right? We go turn the crank again. We get this exponential miniaturization, Moore's law. The computers that used to take a gymnasium, then took a shoebox, then they were on a chip, and now they're in your pocket. Miniaturization in energy, miniaturization in size, and maximization of what they can do as more and more bright lines start to apply them. Then we expand the network. You really couldn't expand the network until you had the computational capability to do compression, decompression, coding, etc. Then what we have had is we had bandwidth expansion. How many of you have sat on a 9600 baud modem line? All right, okay, yeah, out in the villages somewhere, okay? Yeah, it was amazing. That's why we started the internet with teletext, because the only thing you could get down and enjoy was words, Then it went to a little bit of screen graphics, and then it went to a little bit of very grainy, low resolution pictures. and then it went to a little bit of higher resolution pictures, and then it went to a little boom, 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 9600, 20, 19.2, 68.8, whatever. Now we're at megabits per second, and you don't even identify with what I'm saying. All right? Okay, it's all taken for granted. But at each time we got more bandwidth, what happened? We gobbled a bunch of industries. And then we got more bandwidth, and we gobbled another set of industries. Then we got more bandwidth, and we gobbled another set of industries that were tangible, that are now virtual. And all those shareholders of those tangible industries are wishing they had changed out of the companies they own. Right? Boom. Then we got wireless ubiquity. Now we don't even need to be connected. Boom. It's wireless. We continue. We turn the crank one more time, maybe. And out pops the iPhone. 2007, 2008. It's only been in our pockets about 10 years. I'm not sure there's been anything that ever changed the world as much as it did in one decade as that puppy. Everybody copied it. Now it's smartphones, but we'll give Apple credit where credit's due for taking the buttons off, for a minimalist approach, and for a maximalist possibility. Said this thing isn't a phone. This thing can be everything. Let's create an app store. Let's create a tune store. Let's create additional opportunities. That is the great virtual conversion. Now, this convergence has had impact on industry after industry after industry. I'm trying to convince you of my initial premise, which is what? That you are living in the middle of the virtual age. This is part of my proof. Not my opinion, this is fact. The encyclopedia in about 1995 massively gave away to something called Encarta from Microsoft that lasted about 2 years, and then Wikipedia said. How many of you have purchased an encyclopedia set? How many of you have ever seen an encyclopedia? Yeah, but you're the old people. Sorry. Records and tapes and CDs to MP3. Okay, electrons. Office Assistant to Siri. Siri can give you the basketball score in a matter of seconds. Books to ebooks, video rental to MP4 downloads. How many of you have been to a Blockbuster lately? Oh, you have? Okay. You have. There's one left in the United States, so it's a long drive. Okay.
We got one in Florida like 2 years ago.
That's 2 years ago. Yeah,
Yeah.
I got you. I think there's one left.
That was like 4 years after we were all together.
Yeah. I think there's one left in Alaska. Okay. I think. Of course, they have long winters there. And maybe more internet service for that matter. Phone reception to voices with photographs with digital imaging, currency to Bitcoin, which if somebody can explain that to me, let me know, okay? Mail to email, clubs to social media, brick and mortar to e-commerce, papers to blogs, TV networks to YouTube, life to Second Life, okay? Kind of interesting what's going on. Do you see my trends? Do you see my point? Every one of those is a virtual representation of something that a mass part of the population did tangibly a generation ago, or maybe as little as 6 or 7 or 10 years ago. A good read that's kind of previous and projecting all of this is from Adam Schmitz, a guy that ran the MIT Media Lab, Nicholas Negroponte. He wrote about all of this stuff without the names back in about 1995. He saw it coming. So what I'm saying is you can see this stuff coming. The stuff I'm going to share with you, the glasses I want you to put on, you can see it coming. Every one of these made for significant financial opportunities for the people that figured it out first and were first movers. All right? Now, a little bit more proof. This comes out of a book by Thomas. Oh, I'm sorry. I've got the old man. Can't remember a thing today. But the book's called Thanks for Being Late, and Thomas Friedman. And so you'll know this, but the point is, the world's largest provider of taxi rides owns no vehicle. The world's largest provider of overnight accommodation owns no hotel rooms, no real estate. The world's largest seller of consumer goods holds no inventory, and the world's largest company in media valuation today writes no stories. Okay, it's interaction time. Who's the first one? Uber. Can I really say they own no vehicles? Yeah. All right. I think the day will come when they do own vehicles, but those vehicles won't have people in them. Be automatically driven. What's the second one? Overnight accommodation. Airbnb, when the book was written about 1.5 years ago, I'm not sure I'm not standing by these today. I haven't re-researched it. Consumer goods, you're going to miss this one unless you're from China. Alibaba. It's not Amazon, it's Alibaba. Alibaba's business model is they sell in bulk, not in individuals, and they sell directly from the manufacturer to the bulk buyer. So they don't hold inventory, yet they sell more consumer goods than anybody in the world. Large market there. And then finally, media valuation. Who's that? Somebody said Facebook. Okay. They don't write the stories. You get to write the stories. You get to tell the whole world your whole life so that they can sell your stuff. I mean, gosh, in America, great. All right. So more of my proof to you that the world is massively changing. And you know the other kicker that's not in here? I'll look this stuff up. The vast majority of you are older than every one of those companies. Those companies started after you were born. I think the oldest one on there is Alibaba in about 1995. But all of the YouTube, Facebook and all that stuff after 2000. And yet, in a matter of a blink of an eye, they have become the largest providers of very basic needs. How and why? Because they did it virtually and they did it with other people's capital. They didn't have to buy the cars. They didn't have to buy the real estate. They didn't have to pay the writers. They didn't have to pay inventory costs. They found a new way to do business. And because this thing's in, that thing is in thousands of pockets, millions of pockets, billions of pockets, I had instant access at the speed of light to anybody that was interested. Amazing world. So what's ahead? I told you I'd give you some eyes for looking ahead. That's the next 3 slides or so here. I think education is going to go virtual. Tectonic Academy, Take Udacity, but those are just the beginning. How about YouTube? When I really got a problem, I get my answers on YouTube. Right? Laughing? Yeah. When I need to figure out how to change a switch on a thermal on a heater in my Techonomics truck that's 15 years old. There's some dude out there that, for whatever reason, put it up there for the exact model, exact same problem I got. I don't know what his motivation was, but I'm glad he did. I can see to it. It's going to change education. Brick and mortar, look out. Healthcare. We got to figure something out about healthcare because the way we're going right now, it's not healthcare. It's just a burden on society. They don't really care that you're healthy. They care that they're getting paid to keep you that way or to keep you safe. I'm not sure. Interactive immersive video, virtual reality. I think that's going to happen. Law, the virtual law, LegalZoom and its predecessor. Delivery. How about drone delivery? What's that going to mean as far as jobs and the distribution channels? And whether you think of drones in the air or drones as little go-karts on the ground, I think it's coming. And manufacturing, of course, 3D printing. And the ability to have virtual inventory because you've simply got all of the data files and it's delivery on demand. So we're back to our buddy we started with. We changed the eyes with YouTube and FaceTime. We've changed the ears and the mouth with Skype. We've changed the hands and the manipulation with Kiva automation. We're changing the brain and we're figuring out what you're going to think before you think it with Google and Amazon and Apple. If you don't think they can do it, they're getting better at it. And we change mail and messaging. So for our buddy, it's starting to become virtualized. So how do you predict the future? I want to give you one other thought on how you can predict the future. You look at what the military is doing today and researching today, because what has happened over the years is that those military applications have filtered down when they finally became practical, when they finally became financially accessible to the masses. So the win-at-all-cost mentality of the military allows them a fertile bed for new ideas without cost constraints. And of course, they have this captive test market called soldiers who don't have liability opportunities. So keep your eye on the military deployments to anticipate emerging trends. And a way to do that is just to regularly read the SBIR, Small Business Innovative Research, proposal requests from the Navy and the Air Force and the Army. They're interesting reads, even if all you do is read the title of what they're looking for. It'll keep you abreast of what the military is trying to invest in. To try to substantiate this belief that I have that a lot of what we enjoy today came from military investments. You go back as far as atomic energy, military use in the 40s, public use in the 70s, digital computer, military use in the 40s, public use in the 60s, microprocessors, 60s, 80s. You can read, but you get the idea. It all started satellite communications, mobile phones, GPS, internet, nanotech. It all started for those military purposes, and now it's filtered down into the general public. So my question for you as we kind of wrap it up here, What's emerging? What do you think is emerging? I've got my list, but I'd rather hear what you think is emerging that's going to massively impact the society that you are about to inherit. I know you got thoughts. Share them. There's no wrong answers. Help me out, Steve. I'm going to put you on the box first. A technology that's about to emerge. Too slow, Stephen.
Oh, okay.
Help me, young lady. I got your eyes.
Drones.
Drones, excellent answer. How about it, sir? I don't have your eyes, but I'm going to see them. How about it? Yeah, you. Pardon? You don't know. Oh, you got to know. You're taking all these classes. You better know something that's going to occur to you. Yes, ma'am.
Microgrids.
Microgrids. Okay. Expand on that point.
Just having instead of transporting power from like large systems.
Okay.
Distributed generation.
Okay. Distributed generation. Okay. Excellent. I just wanted to understand you. I'm not disagreeing. I just want to understand. Yes, sir. AI, deep data dive. Okay. Some of y'all are probably working in that stuff. I hope it's going to have a future. All right. One more. Pardon me?
It's already happening.
It's already happening. They're guessing what you're going to buy before you buy it so they can give you 3% off and get you to push the button. All right. Here were my thoughts. Drones, genetics, directed energy beams. Why would we want directed energy beams? So that we can take that microgrid and do it without any losses, okay? Graphene. Didn't hear any material. There are no material sciences folks in here. I think graphene is going to unlock nanotechnology. It's going to unlock things in the medical field that you just can't even imagine. And there's a local company that's licensed some things with the Oak Ridge National Laboratory right out on Hardin Valley that's trying to figure out how to make it in quantity and mass in sheets. I think they'll get there. Nanotech, deep data, AGVs, automatically guided vehicles. I can't believe some of you didn't say that. That's going to be a massive changer, and we're already beginning to see it. You know, Tesla has a product on the marketplace. You set it on the interstate, and you just tell it where you're going, and it beeps in 4 hours and says, hey, it's time to get off. That's it, the battery lasts. Humanoid robotics, social media, EMP weapons, battery advancement, multi-material printing, performance-enhancing drugs, cryptocurrency. That's all coming. It's all not science fiction anymore. It's hard to write science fiction. It's changing so fast. So I think this vertical age is upon us. Industrialization, electrification, communication, space exploration, computerization, digitization, and now virtualization. Destiny, ability to do more and more with less and less until you can do just about anything from just about anywhere, just about any time with nothing at all. All right, now, this is for you. I don't know who runs CURENT, but you got an interesting mission statement on your website. All right, a nationwide or continent-wide transmission grid that is fully monitored and dynamically controlled in real time for high frequency, high reliability, low cost, better accommodation of renewable energy resources, full utilization of energy storage and accommodation responsibly. Great. But you got one missing word in my humble opinion. What is that missing word? There's just one missing word. It's a very good mission statement. I'm not trying to be too sarcastic with you, but I'd rather just knock you upside the head before I leave. Well, I wish I could put virtual in there. Yeah, see, there's my alarm. I'm done. Only one. That's interesting. My humble opinion, the one word that's missing. Secure. Reliability is not secure. Completely different thought process. And to be honest with you, I'll take our current grid if I know it's secure, but I know it's not. To me, the most important issue that ought to be on that mission statement, it ought to be the center of some of your research to figure out how to make this puppy secure. Yeah. I figured you are. It ought to be in your mission statement. But what now?
No, it's not. What about to change that?
I think it ought to be there. In my humble opinion. So I was just having some fun with you, okay? Just to let you know, I did personalize this presentation one slide. All right, I'm done, I think. Well, this one's fun. I'll skip it though. Any questions? Well, this is a tough audience, I'm telling you.
What is that one you
What is that one I just skipped? Well, that's a question. I'll answer it. I actually am preparing this. I'm doing something out at the Oak Ridge National Laboratory for Engineers Week next week. So there's the theme for Engineers Week this year is Invent Amazing. And so they wanted me to talk about technology and progression and all that kind of stuff. So I added this slide for them, but since I was editing for them, I dropped it in here for you. This to me is the most amazing example of the virtual world that I can share with you. And it'll take about 5 seconds to pop up. There is, in the faith tradition that I have, there is a last commandment from my Lord. And he said, go and take my word to all nations, creating disciples among all people. And so 17 years ago, I met a guy who was the product manager on the first Macintosh computer. He had worked directly under Steve Jobs, and he'd gotten fired like 7 times. But he basically, a Marine, brilliant guy, and he said, I want to present the gospel 1 billion times by 2020 using the internet. And at that point in time, the basic way that the gospel was presented was somebody walking into the jungles 2 by 2 showing pictures. And so what he did is he started a network that's turned into about 180 different websites in 25 different languages that basically present the simple basics of the gospel. And if you're interested in more information, boom, you click on it and you're in email correspondence with somebody that can take you to the next level. What you are seeing in this is a real-time, this is not made up, this is the real-time URLs, not URLs, whatever it is, the spot where somebody's coming on at the nearest cell tower right now, either getting that information or responding to that information. And that's amazing. So and his goal set in 2003 was 1 billion presentations by 2020. I thought he was nuts, but it was right after I had an IPO and I funded him to get it started. And they hit 1 billion in 2016, and they're now at 1.79 billion presentations of the gospel with acceptances out of about 10% of the people it's presented to. So kind of interesting. I think that's amazing technology, an amazing use of technology to bring peace, love, harmony, whatever into the world. So not trying to proselytize it. I'm just sharing with you some examples of a virtual world, because this, with a staff of about 30, does the work of, in essence, 2 million missionaries over the years. That's virtualization in a magical way. Thanks for asking. Okay, other questions? Well, it's been a pleasure talking to you. I hope you got some ideas that we are in a virtual age and some ways to see and predict what's coming, because it's coming at an exponential rate. Okay, thank you.